So now we're going to talk a little bit about switching back and forth between what we call improper fractions and mixed numbers or mixed fractions. To give you a definition, an improper fraction this is any fraction where the numerator is a larger number than the denominator. For example, something like 9/8. This would be what we consider an improper fraction. Because there's actually more here than just a small amount. We have a whole number with a fraction of this. In fact, 9/8 is equivalent to saying 1 and 1/8. And we'll talk in a minute about how to convert between these two. But this is an improper fraction. Something like 2/3, this is not an improper fraction because the number on the top is smaller than the number on the bottom. Basically, an improper fraction is a fraction whose value is greater than 1, whereas a proper fraction number is smaller than 1. So let's talk a little bit about how to convert back and forth between these. For example, how did I get from 9/8 to 1 and 1/8, and how would I get back? Let's start converting from the mixed number to the improper fraction. That tends to be a little easier, but actually both of them are pretty easy, so hopefully you won't have any problems. So let's start with something like 2 and 2/3. This is a mixed fraction. You have 2 wholes and then 2/3 of whatever. So maybe you have 2 and 2/3 apples, for example. We want to convert this to an improper fraction, to where the denominator is smaller than the numerator. So this is a pretty easy process. What we need to do is take the denominator of the fraction part, multiply it times the whole number, and then whatever that resulting number is, we need to add it to the denominator of the fraction part. So for example, here we have 3 times 2, which is 6, and then 6 plus 2 is 8. So we take that number and that becomes the numerator of our improper fraction. And then the denominator stays exactly the same, so we just have to transfer this 3 over. And so really the only part that we're changing is the numerator here. So the denominator should stay the same. So again, we said 3 times 2, which is 6, 6 plus 2, which is 8, and we'll put the 8 right here. 3 stays the same. Another example would be something like 5 and 1/7. Again, we'll take the 7, multiply it times 5, and get 35. Then 35 plus 1 should be 36. So 7 times 5, 35. 35 plus 1 is 36. And then again, the 7 doesn't change. It is still our denominator of our new improper fraction. So 36 divided by 7, 36 sevenths. Going the opposite way is also not so bad. So let's say we started with 36 sevenths. Okay, and I want to create a mixed fraction out of this. Well, all we have to do is divide 7 into 36, because 36 sevenths, really what that means, that fraction symbol just means division anyway. So we'll just take 36, divide it by 7. So 7 will go into 36 5 full times. That's where the 5 comes from in our mixed fraction, the 5 whole number. So 5 times 7, that's 35. And we end up with a remainder of 1. So we have 7 goes into 36 5 times with a remainder of 1. The way this becomes a mixed fraction is we take whatever the whole number was right here, that becomes our whole number in our mixed fraction. The remainder becomes the numerator, and then whatever we're dividing into 36, or whatever we're dividing here, becomes our denominator. In fact, the denominator, again, doesn't change. So the main thing to remember is that the 5 goes here, and then whatever the remainder is, that's going to go here for the numerator of the fraction part. The denominator stays exactly the same. Let's try a different one. So maybe we can take 39/5. I want to turn this into a mixed fraction. Well, again, I'll just take 39 divided by 5. So 5 go into 39 7 full times. So we get a 7 for that the whole part of our quotient. 7 times 5 is 35, and then when we subtract 39 minus 35, we have 4 left over. So we get 7 with a remainder of 4. That's how many times 5 goes into 39. So it goes in 7 full times, so 7 becomes our whole number on the fraction. We have a remainder of 4, so that becomes the numerator of our fraction part, and then the 5 stays the same still as our denominator. So we get 7 4/5. And in fact, you can check this, right, because you know how to convert mixed numbers back to improper fractions. So I should be able to take 7 times 5, which is 35, and then add 4, so 5 times 7 is 35, 35 plus 4 is 39, and 5 stays the same. Sure enough, we have the number that we started with. So you can do this with any of the mixed fractions and improper fractions. You can always check by simply converting it back using the opposite process. And then you can see that if you converted it correctly or not. And if you didn't convert it correctly, of course, you need to go through and find where your error is. One other conversion that we're going to look at is how to convert between decimals and fractions. So a conversion between the decimal number and fraction. Because fractions and decimals are basically the same way of representing, or two different ways of representing the same data. Any decimal, well, I should say, any decimal that we can write down, we can also represent as a fraction, and vice versa. There's a few that get kind of tricky as far as going back and forth, where sometimes a fraction is a little nicer than the decimal version, and vice versa. But essentially, we can convert any decimal back to a fraction, any fraction back to a decimal. Let's start with the decimal to fraction conversion. So maybe something like 0.12. What we need to ask ourselves is, how far over are we in the decimal? What place are we? Well, this is the 10th place. This is the 100th place. And then this is the 1000th place in a decimal. If we went over one more, it would be the 10,000th place, then the 100,000th, then the millionth place. Since we go out to the 1000th place, all we have to do is take our 0, 1, 2, which in this case, we don't really need the 0, so we can just think of it as 12. And we just have to put it over 1,000. And voila, we've converted it into a fraction. Now, of course, you want to write this in its simplest terms. So we can, of course, take a 2 out of this, so that becomes 6 over 500, and we can take another 2 out of it, and this will become 3 over 250. So in this case, 3 over 250 is the simplest form of 0.012. And if you type 3 divided by 250 into your calculator, you should actually get 0.012, because that's the way that we'll convert back. We'll just do the division. We'll do that in just a second. What about when there's a whole number in the front? So something like 5.1734. Well, the whole number is just a whole number. So whenever you're converting this to a fraction, that just becomes the whole number of your mixed fraction. So the 5 from the front of the decimal point will just become the big 5 in our mixed number. The only part we have to really convert is the fraction part, because the fraction part is the leftover, the part that's smaller than 1, just like we were talking earlier with proper fractions and improper fractions. So we need to convert this 1734 into a fraction, 0.1734. Well, again, this goes to the 10th place, the 100th place, 1000th place, but here we actually make it all the way out to the 10,000th place. So all we have to do is take 1,734, and and then divide it by 10,000. Now this will reduce. I'll let you do that on your own. This is the way to get into the fraction form to start with. Then of course you can reduce afterwards. Now of course not all of these will go all the way out this far. You might have some of these that just go out to maybe the 10th place. For example, something like 3.2. This will just be again 3 and then 2 over 10 because we only go to the 10th place, which will reduce to 3 and 1/5. So we don't have to do too much work for that one. Usually the smaller the decimal, the less you have to think about how it's going to reduce, and usually a little less arithmetic, not always, but most of the time. So let's go the other direction. So let's start with a fraction and turn it into a decimal. For example, 2/5. How does this turn into a decimal? Well, I mentioned before that a fraction just means division. 2/5 just means 2 divided by 5. So if I want to turn this into a decimal, the only thing I have to do is divide 5 into 2. Like this. So 2 divided by 5. Now, of course, 5 doesn't go into 2 evenly. Since 2 is smaller than 5, I can use this trick and think of this as, instead of 2, I can think of it as 2.0, since it has the same value. And then I just have to make sure that whatever decimal point I put right here also goes to the top for my answer. Now I can say, well, 5 goes into 20 4 times. And then my answer becomes 0.4. So that is the decimal version of 2/5. And in fact, if you take 0.4, that's really 4 tenths, right? That's the other way of saying it. That's actually the more proper way of saying it, is 4 tenths instead of 0.4. 4 tenths reduces down to 2/5. So actually, if you say these properly, then it makes the conversion really easy. So, for example, 125 thousandths is really the proper way to say this number, since it goes to the thousandths place. So 125 thousandths, automatically it's in fraction form in your head because of the way you said it. 125 thousandths, and then you can reduce from there. But I'm getting backtracked a little bit. Let's get back from converting from the fraction to the decimal. There are cases where going from a fraction to a decimal can create some problems. For example, 1 divided by 3. Okay, so I'm just going to take 1 and divide it by 3. That's how I get my decimal. Again, 3 won't go into 1, it's too big. So we create 1.0. We change the 1 to 1.0, and then also put the decimal right here in the same position. 3 will go into 10 3 times. Okay, then 3 times 3 is 9. Subtract the 9, we get a 1. Again, we're dividing 3 into 1. So we'll add a 0 out to the end and think of it as 3 going into 10. Well, 3 goes into 10, again, 3 times, and then 3 times 3 is 9. End up with a 1 again, add a 0, 3 goes into 10, 3 times. You can see what's going to continue happening. We'll just keep getting 3s forever. The 3s will never stop. They'll just keep going forever and ever and ever and ever. So the way we deal with this is simply by putting a bar over one of the 3s. So a bar over the 3 indicates that that 3 repeats forever and ever and ever and ever, and it never stops. Okay. Likewise, if you have a bar over 2 numbers, so whereas 0.3 with a bar means 3, 3, 3, dot, 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 0.12 with a bar means that the 1, 2 repeats over and over and over again. If you have the bar only over a specific number, so like 2, 3, 5 repeating, then you get 0.63, and then only 5 repeats forever and ever. So the only the part that has the bar, that whole part repeats over and over, non-terminating, never ends. Okay. but it does repeat over and over. Let's try another one. How about 5 1/10? In this case, remember the 5 is the whole number part, so we know our answer is just going to be 5 point something. The only thing we have to convert is the 10th part. Now, if you're clever, you realize that 1/10, that's the same thing as 0.1. So that works well. However, let's pretend that we don't realize that. Then the process would be to take 10 and divide it into 1. Again, we'll think of this as 1.0 and then put our decimal in the same spot. So 10 goes into 10 one time, and we have a remainder of 0, so we're done. So this becomes 5.1. How about 6 2/3? Well, again, the 6 is the whole number part, so it'll be 6 point something. And then to get the 2/3 to convert, we'll divide 3 into 2. Okay, so this becomes 2.0. Put the decimal in the same spot on the quotient line. 3 goes into 20 6 times, and 6 times 3 is 18. We subtract 20 minus 18, we'll get 2. Again, we'll add a 0. 3 goes into 26 times. 3 times 6 is 18. You can see again we're kind of running into the same problem that we did before, where we're just going to continue to get 6s no matter how many times we do this over and over and over, because we continue to get 20 in the bottom whenever we subtract. So in this case, this will be 6 point, a repeating 6. And again, just over the 6 that's in the decimal place gets the line. We don't put the line over the whole number 6 because it's not repeating, only the one that's in the decimal. And so maybe we'll do one more. So how about 5 32nds? Actually, let's do a slightly different one. How about 5 6? We'll do that. 5 6. Convert this into a decimal. And again, we'll take 5 divided by 6. This becomes 5.0, decimal in both sections. 6 will go into 50 8 times. And then that will give us a 48 here. So when we subtract that, we get a 2. 6 will go into 20 3 times. You'll notice again, we start getting this pattern where every time I'm going to get a 20, and then 6 goes into 23 times. So 5 6 will turn into 0.83, but the 3 is going to repeat forever and ever and ever. Now you're not always going to get one that continues, of course. It just kind of depends on the way the problem is set up. If I had changed this to be, for example, we did something like 1/6. Well, actually, it's not a good example. Maybe we'll do something like 3/4. Okay, 3/4 is the same thing as 0.75 in decimals. But we can still use this process to figure that out if we're not 100% sure. So 3 divided by 4, this will become 0.0. 4 will go into 37 times. Then we get a 2 left over, so 4 goes into 25 times. So in this case, we get 0.75. So some of them will repeat, some of them will terminate. Some of them will terminate, but only after a very, very long time, maybe after 4 or 5 digits. The time that you know that it's going to repeat is whenever you start getting these repeated processes that are going on whenever you're multiplying out and then seeing what will divide into that number. I do want to mention one last thing. I said that in general, you can always convert between decimals and fractions. That's not 100% true. There are certain decimals that will not turn into fractions. We call these irrational numbers. And we've probably have already talked about that in class. I'm making this before the first class, so we'll talk about that the first day of class. But an irrational number is any number that cannot be written as a fraction. That's actually how it's defined. And so those are decimals that would be non-terminating, so they would go on forever, but also they would have no patterns. There's no repetitions in the numbers. So for example, pi, if you look at the digits of pi after the 3, they go on forever, they never terminate, and also you can't find a repeating pattern that's going on either. So because of that, you cannot write it as a fraction. We have to have repetition going on in order to be able to do that.